Each nation aiming for global dominance is eagerly focusing on the US, China, Russia, and North Korea. None are left out. However, the US has something they all don't: a highly advanced sixth-generation fighter jet the world has never seen. This 300 million-plus aircraft could end any conflict aimed at the US before it even begins. Equipped with a flying suite that enables it to strike targets on the other side of the planet, a deadly weapons suite, and a stealth suite that allows it to remain undetected. This new fighter is an aerospace revolution the world is likely not ready for. The Next Generation Air Dominance (NGD) program is set to develop the fighter jet that will ensure the next era of American air superiority, just as the F-22 Raptor has done so effectively for decades. The new NGAD fighter will be sleek and aerodynamic, featuring a streamlined, blended fuselage that defies the laws of physics. Inside this fuselage will be three conflict-defining technological marvels: an AESA radar, stealth capabilities, and adaptive cycle engine. The NGAD program is also developing new and advanced active electronically scanned array AESA radars, which will give the fighter an unprecedented edge. AESA radars have many advantages over previous generation. They eliminate the need to mechanically scan in all directions, thereby avoiding the cumbersome moving parts of their predecessors, making them far more reliable and, in some cases, smaller and lighter. They can scan vast volumes of airspace and large areas of the Earth's surface rapidly, while simultaneously tracking multiple targets with peak accuracy. These capabilities are enhanced by high sensing resolution, resistance to electronic warfare attacks, improved performance against stealthy targets, and their own low observability. For even better performance, the NGAD fighter will forgo traditional radar mounts in favor of cutting-edge, electronically engineered smart skins integrated into the aircraft's fuselage. This allows the AESA radar to offer a level of sensor fusion never seen before, combining the functions of sensor electronic warfare and communication systems into single, multi-mode AESA arrays. Rather than having multiple systems each performing one task, AESA radars alone can now do it all: fast scanning, spherical coverage, very high-power electronic warfare, data identification, friend or foe recognition, precise narrow beam capabilities, and wideband functionality. The data from all these functions are fused to create a detailed, seamless tactical picture of the battlespace. Using such autonomous AESA radars would make the aircraft's systems easier to upgrade, both in terms of software and hardware. Testing and validating the various functions could also be streamlined significantly under the NGAD program, which would be especially useful. NGAD is touted by the Air Force as a program that will birth an entire family of systems, including the manned sixth-generation fighter, drones, and more. Should the manned and unmanned aircraft share the same AESA radar family, it would not only allow for more seamless integration and economies of scale, but could also be a boon for maintainers working in the field. The commonality of replacement units and parts, as well as having fewer overall system types to maintain, would simplify and integrate critical maintenance tasks. Updating core software would also be more of a do one, finish one scenario. It's important to note that this level of sensor fusion is still a delicate concept, requires skilled hands and minds to pull off. However, with the benefits it offers and the extraordinary American talent working on the NGAD program, it's only a matter of time before it's achieved. What makes 20-ton flying vehicles nearly invisible in the sky is groundbreaking technology that the NGAD fighter will capitalize on. Stealth is not a single technology that's simply installed on a fighter, but rather a set of measures that ensure both the naked eye of adversaries and the radar waves of enemy radars can't detect the NGD fighter as it silently hovers above them. To be stealthy, the fighter must, among other things, reduce its radar cross-section, infrared signatures, and acoustic signature. While the NGAD fighter's exact approach to these is still a top-secret mystery, tucked away in a chest at the bottom of the ocean, educated guesses and assumptions can be made. Radar cross-section is a measure of how much radar energy an object reflects back to the source. If the source receives too much radar energy, it knows that an aircraft is in the air. So, to avoid being shot out of the sky, an aircraft must return minimal radar energy. In line with this, the NGAD fighter is shaped and designed to have smooth and precise surfaces that deflect radar waves away from the source, rather than reflecting them back. The fighter will have no vertical stabilizers to reduce the number of reflective surfaces. It is the first fighter in history to have such a design. The aircraft will also be coated with radar-absorbent materials that absorb or scatter radar waves rather than reflecting them. To reduce the fighter's infrared signature, cooling systems born of the same DNA as the North Pole are used to cool down the aircraft's engines and exhausts. In addition to being cooled, fighters' engines and exhausts are shielded from the direct view of infrared sensors. Finally, the acoustic signature must be minimized. Acoustic signature is essentially a measure of how much noise an object makes. The NGAD fighter must be dead silent in its operation. One thunder, one engine hiccup, or one misstep could be the difference between a successful mission and an encounter with a surface-to-air missile. To keep its acoustic signature low, the NGAD fighter must have engines, propellers, or fans and other technologies specifically tailored for noise cancellation, noise masking, and other sound reduction operations. These and more will combine to enable the fighter to access anti-access areas undetected, linger for a few moments, and then execute its mission. The engine will power the NGAD fighter. Fighter is currently being developed under the NGAD, Next Generation Air Dominance Program. NGAP, meaning Cutting Edge Adaptive Propulsion, is a significant NGAD sub-program that is in pursuit of a revolutionary jet engine. So revolutionary, in fact, that nearly $3 billion in contracts have been awarded to Pratt & Whitney, General Electric, Boeing, Lockheed Martin, and Northrop Grumman. The latter three don't typically build engines, but they are the most likely manufacturers of the NGAD fighter. So awarding them engine contracts could result in a groundbreaking new type of airframe engine integration. The new NGAP engine will reportedly be an adaptive cycle engine that enables the fighter to switch between more speed and more range as needed. A level of flexibility the world has never seen before, but now expects. Adaptive cycle engine concepts are designed for precisely this purpose. Also known as variable cycle engines, these jet engines are intended to operate efficiently under subsonic, transonic, and supersonic speeds, making them suitable for cutting-edge military aircraft and supersonic travel. They can switch between high-thrust and high-efficiency modes, allowing them to adapt to different flight conditions and choose between going farther, speeding up, or an optimal combination of both. Typically, designers would have to choose a configuration that works best for the fighter in question. But with adaptive cycle engines, the fighter can enjoy the best of both worlds. Adaptive cycle engines today are built using a three-stream architecture, where a third bypass stream can be used to increase the bypass ratio when fuel efficiency is required, or to direct extra airflow to the core when greater power is needed. The engines developed under NGAP follow this concept, so when they enter service, they will be America's biggest jet engine upgrade of the century. With new AESA radar systems, new tailless stealth designs, and new adaptive cycle engines in development, combined with an arsenal of directed energy weapons, all signs point to an NGAD fighter that is stealthy and deadly enough to be an invisible and unstoppable force. The Air Force, through its Secretary, Lieutenant Colonel Frank Kendall, revealed that the service's future air dominance plan revolves around 200 NGAD fighters working in tandem with 300 F-35 Lightning IIs. Combined 5th and 6th generation fighters will each be assigned 2 unmanned loyal wingmen as escorts on missions. Over $4.2 billion has been spent on the NGAD program so far, with an additional $11.7 billion to be spent between fiscal years 2024 and 2027. And even more, up to $40 billion will be spent on the program overall. The resulting fighter will begin entering service around the 2030s to replace the current top air superiority fighter in the world, the F-22 Raptor. The 6th generation of fighter jets is finally here, and they promise to be the most exciting, complex, and awe-inspiring pieces of military technology the skies have seen in a long time. To ensure they fulfill this promise, subscribe to this channel and give this video a like. Thanks for watching.